Hello, welcome to our CSCI 430 operating system. And for today, this part mainly we will go through some questions related to the process and give you the sample code you can execute and observe. Mainly is like we're using those sample code to um, simulate. Okay, just like demonstrate how it works. Okay, later if you have some exercise that you can modify, so make it more like closer to perform like simulate how the operating system like performing. Okay, including create the process child. Okay, and when we move on, of course, we will recap what we talk about like processes. Okay, so quickly we talk about the process. So it like instant the program in execution. Okay, with different stage. Of course, including the program code, data, some execution stage, right? So all this and part of it is the process stage, including new, ready, running, waiting, terminate. Okay, so all these are let's say if we have a 5 stage um process, so including like when we create and then when they are ready, maybe we have the queue if you remember, supporting running, and of course we in running process stage, and we do have different type like scheduling mechanism. Okay, we will do or teach in the following lectures. Okay, of course you will just need to know in this moment. So in different stage, what they going to do, like waiting for event. Okay, if they finish, but it will be terminated. Okay, of course we have the PCB and the process control block. So including all those data structure used by the OS to manage processes. Okay, including the process ID, PID, stage. So that we talk about the stage, the PC program counter, the CPU register. Okay, and pretty similar hierarchy to the threads, where we talk about the multi-threading. Okay, so is that what we covered last time? And when we try to create a process, or how can we manage a process, so right here, how can we do that? I will give you the sample code. You can try to try to execute. So mainly we are using the C++ um, language to using the fork function code to create a child process. Okay, so once you execute, okay, and then you can observe how the child process like print the message and the exit. Okay, what you need to do, just execute and run the program. Okay, I already uploaded the source code. You can download from the tutorial and then just execute it. Okay, and also we later I will give you more exercise, including the assignment. I'm going to make it available. Okay, so later, so you can do it. So what you need to do after you execute it, you need to able to answer, like let's say what happens when we have a call system call like the fork function. Okay, and how can we verify the process creation was successfully. Okay, how can we print a message showing the PID? Okay, all this, and also how can we observe like what's the difference between the process ID of the parent child? So do they have do they have any co-relationship, or like can you tell like what's the differences between those IDs, the numbers? Okay, so when you execute, so you can try to tell. So far, I will give you the answer, but of course you can match it. Okay, so you can observe. So once you execute the fork function, okay, so it's going to create a new process. Okay, so by typical case like calling process, and this new process is referred like as the child process. Okay, and then the original process is the parent process. So you need to know. So both processes like continuous like executing from the point like where the fork function was like called, but they have different process ID. So you need to know. And also they are like executing until we finish terminate. Okay. If this process like, lasts longer, then of course we have different scheduling mechanism. Okay, so if they like maybe if you're waiting for certain event, then also we will like putting in the waiting list. And here's the things when we are writing the pseudocode and later in the assignment, or when we are designing, okay, how can we getting the resources? But when we talk about sharing resources, okay, because if we have an identical process, okay, the parent and then the child, and we are going to get the same resources because we talk about the virtual way. And then if you remember, then how can we use an exactly same statement source code and then try to checking the availabilities, okay, and make sure we can get the same using the same source code and then get the same resources. Okay, so they have no like conflicts. Okay, so here's a really important. That's why we need to do some thinking, not only for separate source code, but how can we use that same source code apply on all the child, even the parent process? Then they can checking the resources available for them. And later, of course, we will cover what's the mutex, okay, or like safety. That's what we cover in our previous lab exercise I'm telling you. And also, let's say, how can we verify those process? Was that like creation was successful? Then we can checking the output of program. So it should including the message. Like this one is like we created a process is the parent, and then what's the PID from the child. And also you can use that command like PS to list the process. So this one is the you can do in the terminal, okay, to check the process list. So we can do it in this way. Then next, we talk about the PID, right? The process ID. How can we tell what's the difference? So they would return the PID of the parent one, also the child one, okay, using a printf with statements. And the PID of parent process is printed on the parent's printf statement, and the child one, of course, on the child itself. So here's the difference when we can tell the process. So you can add in the message. You can say, okay, the parent one was the child one, so you can put it for the different when you have a call the system call fork function. Okay, you can observe it. And when you keep going, we talk about the management of the process. How can we manage those processes, like using command line, including the PS? Okay, so to list it and then the top, okay, H top, okay. So to view the running process and their state. Okay, for different windows, we have different process. If you are interested, let me create a terminal, okay, to open it. So because for the Mac it's also slightly not the same, but you can use like all these command line, okay, to show all the process. Right here you can see the PID. Okay, so what's the command I'm using when let's say I have the zoom, okay, turning on, and then when even executing the top, you can see right here. And of course the percentage of using CPU time, okay, all this and following what's the stage. So what's the running stage? Sleeping, okay, most of them you see that in the sleeping stage, and not so many of them in running, okay. But and also maybe there's some other information using the CPU, so okay, resources, okay, and of course also memory. So also you can check yours, okay. So if you're interested, you can try to execute. So no matter Linux system, Mac system, or Windows, you can find all this content. Okay, and that's how you can find it. And I'm sorry, you can, let's say if you want to take the snapshot of the like current process, you can using the PS, AUX, like the real-time monitor process, HTOP, the enhanced the interactive process viewer. So depends on, maybe not all of you have this one, but at least the PS or top, you can use it. So you can check, okay? And as a follow-up, let's say we talk about the system scheduling switch between the multiple process when we move on to scheduling more. But right here, just like when you look at the question, that you have some pictures. So it can help us step into the next chapter, then it will be easier. And then how about, let's say, the time-consuming tasks affect the process execution scheduling, or like what's the observation, how can we make by the multitasking? So it's the question. And of course, including the process stage. So how can they be changed during the execution of the program? Also, how does the system handle the multiple process? So all these questions will help us to give an idea. Okay, so when we start to discuss, okay, about the tasking, okay, multi-threading scheduling, okay, or the we got different for the safety connection. Okay, so all these. Okay, so in all the initial process, all the child process, so they'll be in the ready when we load it. So when it start to execute, we of course like move from the brain from the ready queue to the running stage. Okay, so if we have the call sleep, so if I right here you see I will give you some example with the simulation. What is it called? Transition. Okay, transition like loading. So from which one to which one, so you can see like different stage. Okay, and of course I'll give you what's the handle if we reset the interrupt. And all this will be the simulation, so you can put them all together to showing. So for the simulation, we just like using the sleep function, using timer and then sleep function to pretending. Okay, we reset the interrupt and then waiting for it. And once it finished the interrupt, we'll go back like you're saying it's done. Okay, so it's the pretending, the simulating thing was the processor and thread. Okay, how they really executing, right? So I would let you to execute, observe. Okay, and also for the assignment, you were doing answer a similar question. Okay, so right here we call the sleep function, and then we enter the like waiting stage, and then the sleep duration is over. That means reset, like let's say 1 second over. So once they complete execution, they will move to the terminate stage. Okay, that's how it looks like. And also, how can we handle the multiple process? Like based on what we discussed before, and we talked about the scheduling algorithm. Okay, allow the process like being switching, okay, the context switching, okay, between process and allow in the multitasking and ensure they have already they received the share the CPU times. Okay, of course, how about details we'll learn about it. Okay, you also have assignment exercise to about it, so don't worry about this part. You just need to know. Okay, and also in this moment, how can we observe the impact of the process scheduling and multitasking affecting? So let's say we create a multiple trials like based on what we have to perform like time-consuming tasks like getting a loop or something running it. So you can modify it. Okay, try to um, simulate. Okay, so here's the kind of like backbone right here, even including my previous week. Okay, so the source code using the fork function create a child, then we can execute, and then using the sleep function. Okay, we're going to simulate. So all these like you try to let you to able to get the answer, including like how the like scheduling, and then how can they do the context switch between the process. So that's how the multiple process like some progress like concurrently. Okay, so they're executing each other's, and also let's say the time consuming tasks. So they will literally maybe like some like longer execution. So it will affect the giving impact on the like scheduling efficiency. So the OS scheduler need to like arrange giving the multiple processes that compete for CPU time, then they will also affect the responsiveness of each process. So you need to know in this moment. And then like if we observe the process multitasking, so we need to know one thing about if they're running concurrently by rapidly switching between them, if you remember the overhead, right? So all those so if those processes they are running simultaneously, okay, but it looks like, but actually in reality, so the serious switching between tasks, and also when we are serving these like in a real-time environment, so it's like can illustrate how the process scheduling and monitoring like crucial for the system performance, especially when we have the multi-threading, like if you know that first. So for the modern computer, we are working on like a multi-thread or multiple process. Okay, so that means that each thread, and then we also compare the differences between the context switching. Okay, what's the alpha hat? Okay, efficiency compare using that thread and then or process. So you need to have a picture about it. Okay, and keep going, and here show you what's the giving one more time the detail, what's the definition of the stage. So when we create the process, it should be a new stage, and then ready, that means assigned to the CPU, and waiting, of course we do have queue. If you remember, there's a QSA, and running, we're running the instruction, that means line by line, and passing to the CPU or processor. And when we are waiting certain event, okay, so if we have some interrupt from IO or somehow that we are waiting, And of course, once you finish execution, terminated, we do have other stage, but we always say stay on that. We are not the basic 2 stage, but we are mainly talking or discussing in the 5 stage um, process this one. And I also have some like source code like using different language. Just want to show you we can use different language to simulate the operating systems management operation. How about to manage all these like process? Okay. What you need to do just like if you're feeling, oh, it's so confusing, I don't know. Actually, it just like telling what's the stage of each process. So even right here, you can see when we're executing, so we're just passing itself and then giving a stage name. So right here, we're passing transit 2. Okay, let's say I transit from the stage like ready to running to waiting to running. Okay, so we are like come back and terminate. And then we giving a random time sleep. Okay, to simulate. So you see, like itself is not really telling how the operating system manage the process, but we giving you the source code. Okay, so just showing, okay, that's how the stage transits, switch, and that's it. Okay, simulating. Even if you have assignment, I give you some source code that you need to fill out. So you need to know the logic, how it works. Then just think about how can we implement a source code to simulate, how to make the like maybe the assignment, maybe the scheduling. Okay, how can we switch it from the different stage, make it work? So, okay, so that's what you need to know. And so far right here, just go through we are simulating as process with the state transition. Okay, and right here I also give you the one is a Python one, so you see running. Okay, the reason why I'm giving a Python one but not the C purpose, I say welcome to modify, change the previous C purpose file to the state transition, but it's actually pretty similar. Just letting you know we can use different language to simulate, okay? Because this one is kind of like for teaching, understanding how it works, okay? And then right here, next one, when we talk about the intercept, I also giving, so it's intercept is the signal from the hardware or the software indicating an event need immediate attention. Okay, so in the field, all these are three we already covered in the lecture part. We talk about the interrupt. Okay, and we do have the hardware interrupt and then also the software interrupt. Okay, so just reminding you. Okay, so we call your memory, and right here, if we have the interval concept, we also on this part I already gave you. Okay, so just simulating. Okay, if we have it and we do have a interrupt trigger, okay, then we have the interrupt handler and then we just sleep. Okay, just let you know, okay, we have this stage. So if you look at the source code, nothing complicated. Okay, so we just say, oh, we have the interrupt handler to handle it, and then um if we do trigger, but for this function it's not really trigger, we just call it. If you need to trigger it as a OS, then you need to keep on listening, right? So you need to have a loop or like waiting for the interrupt. Let's say the OS waiting for interrupt, then we will jump to another function. Okay, and of course like third thing, so is using to simulate the process like execute and handling for the interrupt. So that's how it looks like. But mainly it's like when we're executing, we need to know it's like in different stage. Okay, it's like instinct is, and also how can they the transition like to the ready stage and then waiting for execute like to be executed and then also like running or waiting all this. Okay, and of course the in if we return back to running stage after waiting and then later after we finish, because in this part is that we just need to like running time, okay, to finish this process. Sometimes it takes more than that, okay. And after we finish everything, it being terminated. So so far everything is like straightforward, and especially for the interrupt handler. So right here, just explaining to you, we have the process like which the points that if we have the interrupt trigger, so 3 seconds of execution. So when I say when we log the interrupt trigger, and then we call the function interrupt handler. So all this, and just for letting you to know how it works. So you can execute and see. Okay, of course, you feel free to modify and change the interrupt. It looks better. Okay, nicer is okay. You're welcome to do that. So we're just like to conclude, just remember all these processes. Like they should be like efficiency, like pause until the interrupt handle is complete. Okay, we're waiting for event, right? So if you need to know the switching from different stage, okay, and after the interrupt is handled, then we will continue its execution. So that's how it works, like, okay. And just need to know one thing in the real OS. So they'll go through like different stage of execution, and it can help. Okay, all this they helping the process scheduling and resource allocation efficiently. Okay, let's say if a process in the waiting stage will not use the CPU resources and will be like paste back into the ready state once they require a resource before become available. So will be like this. And also right here, if we talk about the interval handling, we say, okay, all this, how can we handle all this in real world or the OS we're using right now? So actually the interrupt can occur like asynchronously. Okay, also they require the immediate attention, right? So all these like interrupt can comes from the hardware, even though hardware or the software we have a system call. Even the system call is you're using is the fork function to create a child. Okay, if when we executing the parent one we process, and then when we receive the fork function, okay, then there's an interrupt. Okay, so we need to create a new process. And then also the hardware, let's say if you right here we have a keyboard, let's say we execute terminal top, and then if I give a combination key like Control C or Command C, it depends on OS, then we terminate. Okay, so all this is the hardware interrupt, but sometimes we have some like network package, all this. And when the interrupt occurs, we need to know like based on what we go through, you just need to know. OS typically is suspend the current process, save the state. Okay, so we're adding to the step. Okay, and then we will execute an interrupt handler. This is like really happening for a handler, but this handler is just for simulation. And after handling the interrupt, then the OS restore the state of the interrupt process and continues its execution. There's a mechanism like it's really working. So you need to know it's like crucial for responsive and efficient operation of OS. Okay, so I need to know. Just more like just an exercise. You can execute, run all these script I gave provide. Okay, so you can see and observe. I hope it can help you know more between different stage and easier to catch this concept. Okay, switching and also transfer from different stage. Just recall the memories of the lecture we covered. And after finish this part, we will move on to the like really more details about OS. Okay, and how can I later we'll cover the safe stage. Okay, and a mutex stage. Okay, so all this we will go for details. And thank you so much.